Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good. So, how's your mathematics preparations going on?
Yeah, good. Like I've always said, every time we make an intro, it's just kind of that continuous like motion of keeping my mind like with maths and like completely like doing exam questions as much as I can wherever I can fit it in. But I've got a test on the 2nd of November, kind of like a main one of like all the year 13 content that we've learned kind of test, kind of a big one. So yeah, I'm revising for that topic by topic and
Okay.
I guess selectively choosing them. So yeah.
So, which topic you want to do today?
Yeah, so I don't know, whenever it comes to like logs or like a bit of graphs, like not that I feel like in the moment I get it. It's just I don't know, there's still a little like not the wholehearted confidence I have. So I don't know, if I did a bit more revision or like practice, I think I'll get
Sure.
rid of that.
Sure. We can take all the functions, including logarithmic functions, and let's see their graphs. Okay. So, you can share your
Okay.
questions with me.
Yeah, so these are just some that I found from that physics math teacher site and things. So yeah, I guess we can work through them.
Sure. Sure. So, okay. So, can you please read the question?
Yeah, so given that 3x to the power of 4 minus 2x cubed minus 5x squared minus 4 over x squared minus 4 equals ax squared plus bx plus c plus dx plus c over x squared plus minus 4,
Mhm.
where x is not equal to plus or minus 2. Find the values of the constants a, b, c, d, and e.
Yeah. So, that should not be very difficult. So, what will you do in this particular case?
So this is the partial factoring where you take so there's a difference of two squares at the bottom. Or when you just divide them, like
Yeah.
the division, yeah.
Just do a long division. That's correct.
Oh
So
yeah.
yeah, just divide, right? That'll be better. So divide by the denominator, which is x square minus 4 in this case. Now, since we have x
Oh,
square minus 4, it is good practice to put a placeholder here, right? You get my point? So
like plus 0x.
plus 0x. So I should rewrite this. This is a very important step. So we'll say x square plus 0x, right? And then we'll write minus 4. Is that correct?
Oh yeah, yeah. Okay.
And then we are going to divide. So now do the long division. Let's check our results. So
So 3x squared.
correct.
Oh, I have to write it in line with. Okay.
Yeah,
Okay.
align it. It is better, you know.
Yeah, yeah.
We can write plus or minus. Minus 12.
Wait, so when do you do partial factoring?
So, it is better to divide and then do the partial factoring if required.
Oh, I see. So yeah, simplify it a bit more and then do the partial.
Yeah,
Okay.
because see, this part is already given to you as the quotient. Now, whatever remainder is there, which is dx plus e, is the remainder.
Right.
Correct? So we'll just get it directly. This is not a difficult straight, but so this gives you minus 2x cubed, and that gives you what? 7x squared minus 4. Now that will go with 2 times minus 2x. Right? So we get minus 2x cubed plus 0x squared minus and minus becomes plus. And see here also we have 4, right? Actually speaking, I should have done a placeholder there also, correct? So I should not bring it anything here, 0. I should have 0x. Is that okay?
Yeah.
Minus 4. Is that, so we'll just put 0. Is that clear to you? So placeholders are important. So minus 2x plus 8x.
I didn't really spot that, to be honest with you.
Yeah, I also missed it.
Oh, okay.
So
Minus 2x cubed plus 7x squared. So plus 0.
now you can compare the coefficients, correct?
Yeah.
So you can write down all the values, and that is how you're going to solve this particular question. So we have ax square plus bx plus c. Let me rewrite what I have, and then you can write down 3x square minus 2x plus 7. The remainder is minus 8x plus 24. So let me write plus here. And then we have 8x minus 8x plus 24 divided by the divisor, which is x squared minus 4. Is it clear? Now you can write A, B, C, D corresponding values, and that should give you the answer, right? So A equals to 3, B equals to minus 2, C equals to 7, D equals to minus 8, and E equals to 24. Is that clear to you?
Yeah.
So that is how you're going to solve the first question.
Right. Okay.
So, okay, let's move on. Take the next one. Yes, next.
Is it similar to that one? Because if you think it's quite similar, we can always skip.
It is kind of similar because you can just factor and add. X square minus 9 can be written as x plus 3 times x minus 3,
X minus 3.
and then you can do it, right?
Yeah, I think that one's fairly straightforward. Yeah.
Third, express this in a single fraction. Again, a similar thing, common denominator you take and then multiply. It will take some time to do it, but then again, you can simplify, correct?
Yeah, that's also a difference of 2 squares. You can just write it in like that.
Yeah, but you can just multiply and get your result. Next one.
Right.
Express as a single fraction in its simplest form. Again, a similar thing, take a common denominator, right? And then just cross multiply and do it, correct?
Yeah.
So all these questions are quite similar. You can move on, take the next one. Perfect. Now it's different. We are talking about functions now, correct?
Right.
Can you please read the question?
So the functions f and g are defined by f x, which is 7x minus 1, where x belongs to all real numbers, and g of x, which is 4 over x minus 2, where x is not equal to 2 and x belongs to all real numbers. So part A, solve the equation f of g of x, which equals x.
Correct. So when you do this, you have to do inside function first. So we are talking about f of g of x, correct? So what is g of x given to you? F of 4 over x minus 2. Is it okay?
Yeah.
So that is f of g of x. Now the question is f of g of x is equal to x. So this becomes an equation which we need to solve. Is that clear to you?
Right.
Now function is given to you f as 7 times x minus 1. So this becomes 7 times 4 over x minus 2. That is 7 times x. This is the x thing, right? Minus 1. Do you understand? 7 times 4. And that is equal to x. Is that okay?
Yeah.
So you can say that is 28 over x minus 2 equals to x plus 1, taking this one on the left hand, right hand side. And then we cross multiply. So we get 28 equals to x plus 1 times x minus 2. Perfect.
Which is
open
x
the bracket.
Squared minus x minus 2.
X squared minus 2 minus 2x minus x minus 2. So we get 28 equals to x squared. We can bring 28 on this side.
But so is it positive x?
Pardon?
Is it minus 2x plus x?
So minus 2x and plus x. Yeah, you're right.
Okay.
Correct. Thank you.
That's right.
Yeah. So we get 0 equals to x squared minus x, and bringing it on this side becomes 30, right? Minus 2 minus 28. And now you can factor this. So 30 is what? 6 times
6 and 5.
So we get x minus 6 times x plus 5. And so we have the answer, x is equals to 5 and x equals to 6. Well, right? Remember, these were our restrictions, plus 2, it cannot be, but this could be these answers. So that becomes our solution. Is it okay for part A?
Yes, yeah.
Now let's look into part B. What is that?
Hence or otherwise find the largest value of A such that G of A is the inverse of F of A.
Okay, so when they say hence or otherwise, so when you do function of a function and And if you do F inverse of A, I mean, hence or otherwise find the largest value of A such that G of A equals to F inverse of A, right? That's the question.
Yeah.
So if I write F inverse, we could use the equation which we have, right? How will you use it?
I don't.
Or yeah, let's do it straight away without getting into that complication. We had done the first one. We got answers 5 and 6, correct? Let me clear the screen.
Minus 5 and 6.
Yeah. Yeah, minus 5 and 6, correct. So now in this particular case, G of A equals to F inverse. You can find inverse of F, right? So what is F inverse?
So y equals 7x minus 1. Okay, so I got f of minus 1 x equals x plus 1 over 7.
Correct. So how have I done it inverse? I have done it reading it backwards, right? So if you see the equation, it says 7 times x minus 1, correct? So what is the reverse order?
The x
Reverse order is
1.
to add 1 and then divide by 7. Do you see? So you get inverse as x plus 1 over 7. Do you see that? So we just reverse order, okay, to find the inverse. So we have F inverse of A will be, so F inverse of A will be A plus 1 over 7. Is that clear to you? And G of A is equal to replace x with A. 4 over
A minus 2.
A minus 2. And both are equal. So let's put this as A plus 1 over 7 equals to 4 over A minus 2. So we can cross multiply. So we get a similar equation as we began with, right? Do you see how 28, correct?
Oh, yeah.
And when you open this up, we get A square minus 2A plus A minus 2. Bring 28 here equals to 0. And you remember, you got this A square minus A minus 30 equals to 0, correct? Now it says, find the largest value of A, right? So
6.
So hence or otherwise find the largest value of A, given that this is equal to this. So this equation is true only for 2 values. And those 2 values were A
minus 5 and 6.
minus 6 times A plus 5, right? Equals to 0, correct?
Yeah.
Minus. So we have A equals to 6 and A equals to minus 5. So the largest value is A equals to 6. Now,
so how, without doing all this calculation, can you just see that it's related to the one that we just used?
Okay. So if I take the function f, see, we are saying f of A, let me do it here. So G of A equals to f inverse of A, right? So now let me take f of G of A. You understand? F of f inverse of A. You see that part now? So you get on the left side, f of G of A equals to inverse of a function is x. So we get the first part. You get the idea? So this is your part A.
Oh.
F of G of A is equals to x. That was the given equation, correct?
Yeah.
So when you have function of a function and what you get is x, that means it is inverse of the function.
Yeah. So it has to be f of the inverse is x.
Yes. So in a way, both were very related. You could have done it from the second question, first derivation also. And that's the hint given to you in the question itself. You get the idea.
Yeah.
So what we have learned here, Amy, this is a very interesting question. And that is, you know, if you have a function here and you put in x as an input, what you get is f of x, correct?
Yeah.
But if you put some other function here, which is g of x, right? And then put f of x in and you get x out, it means what? We actually did the inverse of the function. We did the inverse. Do you understand?
Yes, yeah.
So that is why we could have used that result. So basically, when I say f of g of x equals to x, and next question was g of A equals to f inverse of A, basically, as we figured it out, it is f of g of a equals to f of f inverse of a, which is equals to x. So I could have used the results in part A.
I see.
After
Okay.
doing these three steps. After doing these three steps. Is that clear to you?
Yes, yeah,
Okay, great.
clear.
Good. Next question.
So that was a good like little shortcut, or especially with the time. Okay. Question 6. So given that f of x equals ln x, where x is greater than 0, sketch on the separate axes the graphs of, so part I, y equals f of x.
Yes.
Part 2, y equals the absolute function of f of x. And part 3, y equals minus f brackets x minus 4.
So let's sketch the ln function, natural log. So this natural log function is kind of like this, correct? So this is y or this is x. So f of x you could write actually. So y equals to f of x, correct? Perfect. Now, you should know that this is always as given here, x is greater than 0. That is the restriction for any logarithmic function. And when will it cross the line?
At
1.
1.
And
Yes.
ln is to the base e. So this will, over here, at e, it will have a value of 1. Is it okay?
Right. Okay.
And it will be 2 for e square, right? So if I write e square, then you get 2.
Yeah.
So that is how you could actually draw a graph. And of course, with minus 1 will be at 1 over e. Is that okay? So those will be your critical points which you can show here. So when you sketch this graph, the critical points for you are, if it is minus 1, in that case, you get 1 over e. And if it is 1, you get 0. For e, you get 1. And for e square, you get 2 as your y value, right? So you get this particular graph for that. Perfect?
Yeah.
Now let's look into the absolute function graph. Absolute function graph basically means what? Absolute value of f of x means non-negative, correct? So here
Means
it becomes negative.
anything below the x-axis has to be flipped above.
This point will come here, and so we'll have a graph which will be kind of like this. Is it okay? And this will remain same. Is it clear to you? So that becomes the absolute value of f of x.
Oh, yeah.
So
Yeah.
it will be divided as a piecewise function where it will be the same as f of x for x greater than 1 or equal to 1, you can include here, and will be negative of f of x when x is greater than 0 but less than 1. Is it clear?
Yeah.
So we get that part. Okay, parts.
So I'll just write like as a side note, piecewise function, just so I can see a relation between the two topics. Okay.
Now
Yeah.
we can do the part 3, which is what? Let me erase all this. So we are now working on y equals to minus f of x minus 4. Can you explain the transformation here, please?
So we are reflecting the graph in the x-axis, and we are doing a horizontal translation 4 units to the right.
Perfect.
Is that wrong? Oh, okay. It's
So-
silence.
So basically, we have again this particular graph. So you know this is the graph which you obtained. So you have to do vertical translation first. You know, multiplication order has to be maintained. So you got to reflect it. So as soon as you reflect, the point on the axis will be invariant, right? So they will remain, and what you get is kind of like this. Is that clear to you?
Yes.
And after reflection, I mean, this point comes here, right? So exactly same distance away. After reflection, you just move it 4 units. This is at 1, correct? So
Yeah.
when you move it 4 units away, it will be kind of like this, where this point
5.
will be 5. So that becomes your answer. Plus, you should actually draw the vertical asymptote here, very important, right? Which will be which will be at,
4.
correct, at x equals to 4. Is that clear to you? Very
Yeah, I would
important.
actually miss the asymptote. It's because the asymptote for the ln x graph is just the axes. So it's really confused. Like it's easy to miss that because it should
Yes.
be like dotted, but
You're
it's
right.
the axes, so you can't do anything about
You're right.
that.
Correct.
Okay.
Next question.
Okay, so just a quick overview of what we did here. So it was just kind of transformations of the graphs. So the simple one was just first starting with our kind of like parent function, and then we kind of like did the transformations with the part 2 and 3. So we had our ln x graph, which we know the asymptote is the y-axis. I meant y-axis, sorry.
Yeah, yeah.
And then we have that. And then part 2, it was having the absolute function, meaning you don't want any negative values. So we had to flip everything that was below the x-axis to the top, and the asymptote is still the y-axis, that hasn't changed. And then for part 3, we first looked at the graph. Instead of going straight towards it, we're trying to like write. I think this is a really important point. I do it now because like you told me, sir, to like write it on the side, so like reflecting the x-axis and then do the horizontal translation. Like it's so clear if you write that out instead of doing everything at once, because you can get multiple transformations in the same one. Like I've seen more than just 2. There's been 3, 4 like that. So yeah, then you've shown the graph, and the asymptote to show is super important. Otherwise you would lose the marks. So yeah.
So they are very clearly mentioned that. Can you please read these 2 lines, Sammy?
Oh yeah, so show on each diagram the point where the graph meets or crosses the x-axis, and in each case, state the equation of the asymptote.
So you get my point? So you have to put it very clearly, right? And
I see.
Perfect.
So you'd have to say x equals to 4.
Yes.
Got it.
Okay, next question, please.
Yeah, so this one.
No. Yeah, can you please read it?
Yeah, so figure 1 shows a sketch of part of the graph of y equals gx, where gx equals 3 plus square root x plus 2, where x has to be greater than or equal to minus 2. Part A, state the range of g.
So what should be the range? Tell me. It's always you have to find this point, right? What is this point? This point is
minus 2. So you sub that in and you get 3. Also,
2, 3, right? So that is your point.
G of x greater than or equal to 3.
Yeah. So the range is that g of x belongs to real numbers, so that g of x is greater than or equal to 3. Is it okay? So write complete in the set form. Next statement.
Right. Part B. Find the inverse of g of x and then state its domain.
Perfect.
Okay.
Now, this is actually a very important question. When you do the inverse, then domain and range will swap. Do you understand?
Oh, yeah.
So let us write g of x domain range first, right? So as far as domain is concerned, we have seen that the value of x is greater than or equal to, as also given here, minus 2. And as far as the range is concerned, we'll write our y value is greater than or equal to minus 2, correct? Now, if I will do the inverse of the function, that is to say g inverse of x, in that case, domain and range will swap. Do you see that? So the domain for this, let me write here, since it is required, will be x is greater than or equal to minus 2. This swap. And the range will be y will be greater than or equal to, so domain becomes, did I write? Sorry, this was 3, sorry. Y was greater than 3, right? Sorry.
Yeah.
Let me read it.
And range.
Let me rewrite. Okay, so this point, as we identified, is minus 2, 3, correct? So as far as g of x is concerned, let me write in light color now. G of x, we have domain as equal to x, which is greater than equal to minus 2, and the range y is greater than equal to 3, correct?
Yeah.
Now for the inverse function, it will swap. So for the inverse function, the domain will now be x greater than equal to 3, right? and the range y will be greater than or equal to -2. Do you see how? It just interchanges.
Mhm. I see. Yeah, yeah.
So that is first thing. Even without finding the inverse, write down the domain range of the inverse function from the function
Oh,
itself.
right.
Well, you only need domain, but that's okay. I mean, domain, is greater than 3 now, correct? So you can write down domain. Now,
Mm.
inverse of a function.
Yeah, there's no harm in writing it. Maybe I need it later on. Yeah. So
So
definitely.
underline domain is this. Okay. So inverse will be you'll swap and do the needful, correct? So can you tell me the inverse of this function?
Yeah. So g of -1x equals x minus 3 whole squared minus 2.
Correct. You're right. So I'm just taking the time to, include the steps. So we get -2, plus x minus 3 whole square equal to y. Or now we can write down that G inverse of x is equal to, you can write like this, x minus 3 whole square minus 2. And it is very important to include the domain right here, because
Oh,
it is not a complete parabola. It is only one side of the parabola where x value is greater than or equal to 3. Is that clear to you?
right. So right next to it, just write the domain. It should be like instant kind of thing. Okay.
Yeah. So it's
So x greater than or
graphically,
equal
this
to
point
3.
will get, so we have a line which is y equals to x. It gets reflected and you get this point here. And so this graph will be kind of here like this. Is that clear to you? So only the right half of the
Yeah,
parabola
yeah.
is going to be there. And of course, this point here is what? It is 3 minus 2. Is it okay? And that's why we are taking right side of the vertex where x is greater than or equal to 3. Correct?
Makes sense. Yeah.
So we're done this part. Can you please read the next question?
Okay. Yeah. So part C, find the exact value of x for which g of x equals x.
Correct. So you can solve this equation, g of x equals to x, which is also the invariant point, correct? So you could actually now do it. So equate, right? So we have got
Yeah.
inverse of this function and that. So substitute x is equals to g of x, which is, let me erase.
Wait, do we just make 3 plus root x plus 2 equals x?
Yeah. So let me erase this. You could use inverse function also, but this is easier to substitute and then find the answer. Correct? So find the exact value of x. So we'll write x is equals to 3 plus square root of x plus 2. Correct? Remember, x is greater than or equal to -2. Now bring it here. So x minus 3 equals square root of x plus 2. Square both sides. So x minus 3 whole square equals to x plus 2. Expand. So we get
X squared minus 6x plus 9 equals x plus 2.
Minus 2 equals to 0. So we have x squared minus 7x plus 7 equals to 0. So how will you find the answer? You cannot really factor this because 7 is 7 times 1 and you don't get 7.
Oh, yeah.
So use the quadratic formula.
So
Minus b.
I can do on the calculator.
That's yeah, you can do on the calculator. B
This is
squared
calculator paper, sir.
minus 4ac, yes, 4 times 7, 28, right? It's a calculator paper, you're right, times 2. So 7 plus minus square root of 121, right, over 2, right? So, so 21 is 7 times 3, 7 plus minus square root, this is your answer.
Yeah.
Now, this is not your answer. Why it is not your answer? Your answer is restricted
the domain
greater than -2, right? So the answer, the only valid answer will be x plus square root of 21 over 2. Is it clear to you? Not the -1, right? So it has an extraneous rule. So this 7 minus square root of 21 over 2 is extraneous, is not part of solution.
Right.
So it should not be included. Is it okay? So the only answer is this positive answer, since you know x is greater than or equal to -2. Is that okay?
Oh, sir, just a quick thing. I checked the answer for the 7 minus root 21/2, and I got 1.28. It's a positive answer.
Oh, is it a positive answer?
That was misleading because you would think it would be negative. I think both are, both are positive.
See, when x is greater than -2, the curve is as given to you, right? We are saying, when is this curve equal to x? Now, this curve is always increasing. You get the idea? The curve is always increasing. And therefore, if I use any value of x, I should not get two answers. I should get only one answer.
Oh, okay.
So maybe there is some calculation mistake. Let me just check. What is square root of 21? Yeah.
That's the value you got with the quadratic formula, the one that you got.
So did we do any calculation mistake? So we have...
It just says make g of x equal to x.
Yeah. So if I put x here, 3 plus x square root of... I should not get two answers. That's the thing, right? So when I square this, I get x plus 2. Okay. X square minus 2ab plus 3 minus x minus 2, correct? So
do we have to do that thing? You know when you say like, oh, no, sorry. No, ignore me.
Minus of this is plus 49 minus b square minus 4ac, 4 times 7 is 28. Yeah. 49 minus 28 equals to 1. Square root of 21 equals to decimal 4.58. 4.58, and we get two answers. I see. Hence, okay, hence state the value of a for which this is equal to this.
It can't be both because of the way it's worded. It says exact value.
No, that's, yeah, exact value is correct, but x value, can you plug in? Okay, so if you plug in x equals to 7 minus square root 21 in the equation, do you get this correct answer?
Into which equation?
In this equation, do you get?
Oh, let me, so we're doing 7 plus.
7 plus will work, right?
You want to do 7 minus?
Yeah.
Okay. So that plus 2 square root answer plus 3. 4.79.
And as such, let me just do it.
4.79.
Square root 21 equals to decimal value 4.58, right? Plus 7 equals to divided by 2 equals to which is equal to 5. One answer. This is 5.79. Okay, approximately. Right?
Yeah.
And the other one, if I do 7 minus square root
1.208
divided by 2 equals to 1.28, 1.2087. Okay, so which is actually greater than minus 2, 1.28. Try this value inside the function. Do you get 1.28? So 1.28
I didn't get
equals to square root answer equals to plus 3 equals to 4.79. So you don't get that answer. Do you see that?
Yeah.
So that is not the right answer. It is an extraneous root. So you can substitute and get check.
Oh.
Only one answer is correct.
That's quite cunning.
Correct. So why it is so, let me just show you the graph once again. When you're saying g of x is equals to x, that means I'm drawing a line which is y equals to x, right? So when I draw this line y equals to x, it will only cross at one point.
Yeah.
It cannot cross at 2 points.
Oh, so even though you got two values which are within the domain, you have to substitute and check, because when I substituted the 7 plus 1.
range is also restricted. The y value should have been greater than equal to 3, and that value is not greater than 3.
Oh, I
That's
see.
the idea, right? So because the
Yeah.
range is also restricted, so you could not take that value. Is that clear to you?
Right. Okay. That's a really important point. Yeah, because I would have been in the exam and been like, both are in the domain, so therefore both answers, and then struggled. But it's so important to sub it back in. Like you said, draw the line y equals x and c. You can only cross once.
One. So there's only one point, and that is your answer, right? So obviously, g of a and g of minus a means you're looking at that value of a when the inverse and the function are same, correct?
Yeah.
So that is the point where it intersects. So that becomes part A. Is this clear to you?
Yeah.
Very tricky
And I
question.
subbed it.
Yeah, it gives you two answers which are domain-wise, but range-wise, no, right?
No.
That is why.
It's because you're so used to just thinking domain-wise, you wouldn't think range. So because you're getting the x values, which are the domains. So yeah. Okay, that's an important point.
Yes, next.
Okay. Oh, yeah, bit of graphs.
Yeah.
Okay, figure 2 shows the graph of equation y equals fx. The points p minus 3, 0 and q 2 minus 4 are stationary points on the graph. Sketch on separate diagrams the graph of part A, y equals 3 fx, f bracket x plus 2, and part B, y equals the absolute function of fx.
So, well, you can do the first function, which is 3 times, that is a vertical stretch. And,
vertical stretch, yeah, by factor of 3.
Horizontally translated 3 units, right? So what I will prefer here is you take up these 3 points, right? The third point is not very clear to you, but anyway, at least 2 of them are clear to you. You can apply the transformation to these points. The transformation is that the xy point really gets to 3 times the y, I should write x as minus x minus 2, and the y point will be 3 times y. Is that clear to you? So the point P will be what? P is minus 3, 0. Well, now we'll go to P prime, or its image point will be, when I add 2 to this, I get minus 1, and when I multiply, I still get 0. As far as the minimum point is concerned, which is Q, which is at 2 minus 4, the y value is multiplied, so minus 12, yes.
Sorry, sir, are we subbing in minus 3, minus 2?
Yeah, minus 2.
How come we're getting minus 1?
Oh, minus 5, sorry. So minus 2, yeah, minus 2. So minus 2 will be 0 here, right? Good.
Okay.
Yeah, so we get this. So 3 times will give me 12 minus, and this is 0. So now you have this turning point will be at 0 minus 12. So let me just put it approximately here. This point gets shifted to this point, correct? We are assuming that to be, and that is minus 5. So it is somewhere here, right?
Yeah.
Exactly. So now you could actually sketch your graph, because that is your maximum. This is your local minimum, and you get your graph like this. Is that clear to you?
Yeah.
And this point we'll only shift it by 2 units to the left, and so we'll have a graph like this. Is that clear to you?
So the best way to avoid any kind of error is to do it your method, you know, where you do x, y, and then follow through, instead of like trying to do it without like writing it logically like that. Because I found myself making a couple of mistakes. Like sometimes you can accidentally like maybe do the vertical stretch to the x coordinate, and then everything goes a bit pear-shaped.
Correct.
So yeah.
Correct. So you can show these 3 points which you kind of moved, right? So vertically stretched, so it was negative, it becomes 3 times the value, and then moving 2 units to the left, you get your points, right, on the graph, and then you can connect those points and sketch. Is that clear to you?
Yeah.
So showed these points, 3 of them, and then we have got our result. Is that okay?
Yeah. Very clear.
Correct. So that is how we'll do A part. Yes. Next part.
So y equals, yeah, absolute function of f of x. So again, just flipping everything below the x-axis to the top.
Correct.
So that part would So where does it cross? Can we find out where it crosses that y-axis or no?
Yeah, it will. This point goes here, right? Just reflect. So this is.
Oh, you don't need to like label it.
No, not really, because if you have a graph with values, you could do it accurately.
Yeah.
But if it is given something like this, you cannot, this value is given to you, 2 minus 4. So you can
So
always
2.
put a 2 plus 4, right? So
Yeah.
And this part will remain same. Is that clear to you?
Cool. Yeah.
So you could label these points, 2, 4, right? Is that okay?
So label the points given.
Otherwise, no other point.
Okay.
Correct. Let's move on. Done. 6 marks.
6 marks. They're quite generous.
There was something like a stationary point, the last statement. Can you please read that statement? What is this statement?
Oh, on each diagram, show the coordinates of any stationary points.
Yeah. So we did.
So I think that's what you did. Yeah. So the P and the Q. Okay. Oh, okay.
Yes. Read.
So figure 3 shows part of the curve with equation y equals fx, where x belongs to all real numbers. The curve passes through the points q02 and p minus 3, 0 as shown. Part A, find the value of f of minus 3.
Correct. So can you find the value of f of 3?
So f of minus 3 is 0.
F of 0.
And right. Then f of 0 is 2. So okay. 2.
Perfect. Next.
Okay. Part B. So y equals, so you have to sketch the curve, sorry, with the equation y equals the inverse of f of x. So you'd have to reflect it in the line y equals x.
Good job. So in this case, there's no equation given to us. So we'll draw this line y equals to x, correct?
Yeah.
And then this is an invariant point. And then we say this point will come here. This point will come here, right? And yeah. So we can just take some points and then reflect. Is that clear to you?
Perfect. Mm-hmm.
Correct.
Okay. Part B. Y equals the f of, don't know how to say this, but
absolute value of x or modulus of x minus 2. So first you do the modulus of x and then bring it down. Do you understand? So
not the other way around. Okay.
Yeah. So this part will only go up, right? So we have this part here, correct?
Yeah.
Rest remaining same. So that is the modulus part. And now bring it down by 2 units. So this is minus 3, 0. So let's bring it down to 2.
Minus 3, minus 2.
If 0, 2, this will come here, correct? So that much is 0 for you, correct? And so likewise, you can now convert this file parallel, correct? And then this.
Yeah.
I'll do it.
So you'd only plot P.
Q dash, yeah. P.
The origin is kind of already labeled, and Q, yeah.
Done. Next part.
Part D, y equals 2 f of half x.
Tell me, what are the transformations?
So you've got a vertical stretch by factor 2, and then you've got a horizontal stretch by dividing the x coordinates by half, which is like multiplying it by 2. So.
Right.
The x coordinates only. Yeah. So let's do your method where you write like x and y, and then.
So what is the horizontal stretch? There is both 2x and 2y.
2x and 2y. Oh, that's nice. I like that. Okay.
So you know the points, right? P,
yeah,
which is minus 3, 0, will go to P
minus 6.
Minus 6, 0, and Q, which is 0, 2, will go to Q prime, which is 0, 4.
0, 4.
And that is it, right? So those are the 2 points. You just plot those 2 points. So first one, minus 6, 0. So you have a point somewhere here. And then you have 0, 4. So 0, 4 you have here, correct? And then just connect them with a graph as shown and done.
Perfect. Yeah. I feel like I'm getting the gist now.
Yeah.
Yeah, that's okay.
Yeah. Read the instructions after the question.
These ones, sir.
Yeah.
Indicate clearly on each sketch the coordinates of the points at which the curve crosses or meets the axes.
Correct. So when we drew, we had the x-intercept, so coordinates of the point. So those were the 2 points which we had actually found, correct? This we found is
Yeah.
0, 4, right? Which we wrote, and this was -6, 0, right? So those are expected to be written. Is that clear to you? Only then you get full marks. Yeah.
We don't need to label, like, so once you do the curve, do you need to label? You know how it says
Yeah,
here,
yeah.
y equals fx?
Yeah.
Do you
P
need to?
prime and Q prime. Yeah, just as we found the values. Yes.
Oh, you do. Okay. All right.
So those steps are very important. You have to do, show the work, and then accordingly sketch.
Because last time I wrote, so let's say I did the transformation on a separate graph. I wrote the values on that graph, like P and Q, and they said that's not the values because P is -3, 0 and Q is 0, 2. I know that, but I thought when you transform it, you still label it as P and Q.
P prime image point.
Oh.
So that'll be a P prime. This will be a Q prime. Is it okay?
So if you did another sketch, is it P
Double
with
prime.
2 dashes?
Double.
Oh, okay. Didn't know that. So let's do that. I thought you were just doing it just because I feel like whenever I do that dash, I feel like it's first differentiation and that. I'm like, oh, okay. That's all right. Okay, question 10.
Yes.
Pure modulus. Okay. Figure 4 shows part of the graph with equation y equals fx, where x belongs to real numbers. The graph consists of 2 line segments that meet at the point q, 6 - 1. The graph crosses the y-axis at the point 0, 11. Sketch on the separate diagrams the graph of, yes, y equals fx modulus function, and then, or the absolute function of f of x, and then part B, y equals 2, f minus x plus 3.
So only label Q prime and just write this as 6, 1. Is it okay?
6, 1. Yeah, so you get triangle like
negative will become positive, and that should give you part A. Rest remaining same. Is it okay? But you bold them. You bold them. You get the idea, right? So that is the graph, but label Q prime, and then write down the function absolute value, right? Next one.
Okay, so y equals 2f minus x plus 3. So you've got a vertical stretch by factor 2. You've got f of minus x, which is a reflection in the y-axis, and then you've got a vertical translation by 3 units up.
Correct. So you get minus of x, and as far as the y value is concerned, it is 2y plus 3. Is it okay?
Yeah.
So these are the coordinates which will transform. So you start with P, which is given to us as 0, 11. So you get P prime, which will be minus of 0 is 0 itself. And 2 times y, 22 plus 3 is 25. You get 1 point. Is it okay? Then you put Q. And Q is 6. Yes.
So just a quick thing. You know when you say f of minus x, is that a reflection in the y-axis?
No, this is inside y-axis. Yeah. So x becomes minus. Do you understand? So if I reflect this on the y-axis, this point is going to come here, right?
Oh,
minus.
Yeah.
Is that clear to you? That minus?
Yeah.
So when you take this point will be invariant for as far as that reflection goes. Now, as far as this point is concerned, which is 6 minus 1, so it becomes minus of 6. So Q prime will be minus of 6. And the y value will be minus 2 plus 3 as 1. Is it okay?
Yeah.
So when you multiply this by 2, minus 2, and then plus 3 is plus 1. So you get these 2 points. So those are the 2 points which should be labeled. So you have 0, 25. So, I mean, we have to really extend this graph because that is 6. So somewhere here we have, this side, 0, 25 will be somewhere here, right? 0, 25, and Q is minus 6, 1. So this is minus 6 and 1. Do you see that? So this over here, minus 6 and 1 means positive. So this will go there.
Right. Okay.
Correct. And that point will come here. Correct. So you could also do it in So those are your critical points to look into. Now let me show it in two ways. I mean, okay, let me erase this all. So first step is we will do 2 times the vertical stretch, right? So let me just do it 2 times vertical stretch. Instead of 11, that goes to 22, right? And
Yeah.
this goes to -2. So we have a graph which is crossing the y-axis at 0, 22, right? So it goes like this. Is this clear to you? And these points remain same. Is this clear to you? So we
Yeah.
have done the 2 times f of x. And now what we do is that we reflect it on the x-axis. So when you reflect it on the x-axis, this point comes here, right? So 6
Yeah.
comes at -6. Is it okay?
-6,
And this remains here itself, and that point will just bring it here. So we say now this is remaining like this. I mean, you understand. So that is how we get our graph when you do the second operation, correct?
Yeah.
Now +3 means that you're going to move it up by 3 units, correct? So when you move it up by 3 units, this comes at 2. And then you have this graph, right?
Yeah.
Now show your work, x, y will get, I did wrong calculation last time. We are multiplying by 2, the x values is -x, and y values is getting multiplying by 2 plus 3, right? So as far as point P is concerned, which is 0, 11, that will go to P prime at 0, 11, 22, 25. You can see that the final point will be at 0, 25. Is that clear to you?
Yeah.
25, right? And as far as the Q point is concerned, which is 6 minus 1, it will be -6 Q prime, -6, and -1 will give me +1. So this will be at +1. Do you see that?
Yeah.
This point will be -6 plus 1. So that is how we are going to get this particular graph. Is this clear to you?
That's clear. Yeah, yeah.
So for
there's
this
2
question,
things.
I will prefer to show all the transformations, right? So we have 3 transformations involved. So first transformation, which is vertical stretch by factor of 2. And second is horizontal reflection on y-axis. And third is vertical translation by 3 units.
So do you show all 3 or just the one that you end up on?
There's no harm, but it is just 2 marks. You can actually just do the mapping diagram and do it. Well,
Okay.
part B is 3 marks. Since it is 3 marks, I'll prefer to do 3 drawings.
Okay. Yeah.
Okay, so I'll prefer to do the second method, that is showing them, also writing me coordinate points, so that I put these points on the final graph. Is that clear to you?
Oh, yeah, because you don't want to mismatch the wrong points on the final graph.
Those are your final points. Is that okay?
Got it.
And write
Yeah.
very clearly that this is Q prime and that is P prime.
Yeah, that's where I lost marks last time. Not going to make that same mistake again. Okay. So that's good.
So
Good
we've done a lot.
Yeah, we've done.
Can you summarize what we have learned today, Amy?
Yes, I can. So I made a few things. So we kind of started off with a bit of algebraic fractions, kind of doing that long polynomial division. And the key point from that was just, those placeholders. So let's say you see x squared minus 4, putting that 0x is super important, because if you miss that out, I don't know, it just kind of loses everything and you can miss numbers and stuff, which are pretty critical. And then after you get your answer, knowing the form that they've already given it to you in, so you've got your quotient and then you've got the answer, and then you can just use partial fractions if you want to simplify it further. So then we started off with that, then we moved to functions. So we did a bit of composite functions, putting functions into like g of x into f of x. And then with that one question, when they had the inverse, it was kind of a follow through. Yeah, so that one we could have done it the long way, but it was only 1 mark. So clearly there was a shortcut. So we figured that one out just by knowing when you do like x and you put it into f of x, you get f of x. And then if you put that into g of x, you would get x back. So we're just doing the inverse. So you could have just used that method for that question. And then we did a bit of, then the rest of it was kind of like having parent functions, like let's say ln x, and then forming that, knowing your asymptotes, and then a lot of transformations. You can get multiple transformations in the same one. So I think I really liked your method of, there are two methods. If it's kind of simple, you can do it step by step, like you showed. So like, let's say you said the vertical stretch, maybe show everything just for vertical stretch. Then you see a horizontal thing, then do the horizontal. If you see a vertical translation, then do that. But if it's too many, then you can do like the image point once you find X, Y, and then show the transformation like that. So yeah, do it slowly, step by step, because especially for my exam board, it's quite high marked, these graph questions.
Yes.
So yeah, get it right.
And one more thing which we noticed in that square root function, that we did get the X value, which seemed to be in domain, but it was not in range. And
that was a sneaky
there
one.
could be only one answer, not two, right? And therefore, you have to think over it and then only report the correct answer, not the extraneous root, right?
Yes,
so and sometimes you can actually put the value back and calculate. Do you get the right answer, right? So we do have extraneous roots when we work with square roots and also with rational functions. Is it okay?
Right. Yeah. And when you sketched it, it made it really clear to me, because we already saw the root x like this, and then g of x equaling x is just a y equals x graph. So it can only cross at that point. So when we had our one thing here, it couldn't have been one, because the range was like below what was required. So it had to be the 5.79 answer. So yeah, that was super helpful, even just sketching a little small diagram on the side.
Right.
So thank you so much, sir. It was really helpful revision. So hopefully I'll be all right on this topic now. Thank you so much.
Thanks, bye. All the best.